you were to take a look at this integral, you'd probably think that it's very, very difficult to solve and takes a lot of time. But what if I were to tell you that you can just use the most simple integration technique, U-substitution? Let's try it. So obviously the first step is choosing our u, but in this case, it's not what you would think. Usually you're going to think that your u is going to be your highest power of x. Your highest power of x is going to be your x to the power of 5. Then you can replace the lower powers of x. That's usually how it works, right? In this case, it's not. And I'm going to have to show you why by choosing our u to be 1 plus x squared. Right? And now let's find our du. And then furthermore, divide by 2 on both sides. And now, to make it clear, the reason why we chose our u to be 1 plus x squared is so we can rewrite our numerator in terms of u. How in the world would we do that? Well, we can further write this integral as x to the power of 4th times x, right? That's the same thing as x to the power of 5. There's no difference. And then keeping our 1 plus x squared, it's obviously going to be our u, but we haven't replaced it yet. And then obviously we're going to keep our dx as well. So now, our du over 2 is going to replace our x and our dx, right? But we still have to replace our x to the power of 4. We've already replaced our 1 plus x squared. That's just going to be our u, right? But we somehow have to find a way to replace our x to the power of 4. Let's kind of look at what we chose to be for our u. If we want to obtain an x to the power of 4 in our integral from our u, we can actually do that. We can do u minus 1 equal x squared, right? And then by squaring both sides, we can obtain x to the power of 4. Remember, in algebra, if you do it on one side, you have to do it on the other. And now look at that. We've obtained our x to the power of 4. And now we can rewrite our integral just one more time to make it clear. X to the 4th over 1 plus x squared, right, times x dx. This is still correct to write it like this, right? And now let's replace 1 by 1. We know that x to the 4th is going to be equal to what? U minus 1 squared, right? We know that 1 plus x squared is going to be equal to u. X dx is going to be equal to du over 2. Look at that. We just went from everything in terms of x to everything in terms of u. Now we can take the 1/2 out, right? And now we have something that's entirely in terms of u. So the next step in this integral would just be to FOIL out the u minus 1 squared. You end up with u squared minus 2u plus 1 over u times du, right? And now, next step, you can write all of these things individually as a fraction with a common denominator of u. And now what you can do is you can cancel out anything that you can inside of your integral. U squared over u becomes u. 2u over u becomes 2. 1 over u stays as 1 over u. And now we can integrate, right? The integral of u is very easy. You're just going to do the inverse power rule, right? You're going to do u to the power 1 plus 1 over 1 plus 1 minus 2u. What's the integral of 1 over x? ln of x. What's the integral of 1 over u? ln of u. And we have to keep the absolute value signs because there's no negative values in the function of the natural log. Don't forget the plus c. And now we can further write this out. U squared over 2 minus 2u plus ln of u plus c. And now we can recall from above that our u is equal to 1 plus x squared. So the last step is always to just replace back in for your u. Squared over 2 minus 2, 1 plus x squared. And then close the parentheses as well. And it's important to know that I dropped the absolute value signs for the ln because of the fact that x squared is always going to be positive. So you're not going to be concerned with any negative values of u. And now look at this. This right here is our final answer. It's the answer to the whole problem right here. It's actually a very simple U-sub problem. It's nothing more than that. And the reason why we chose our u to be 1 plus x squared is simply so we can just rewrite our numerator in terms of u, and it makes it much, much easier. That is how you solve this problem.